welcome to A Little Bit of Everything. My name is Paul, and today we're going to show you how you can create a very capable CNC machine that can cut anything from wood to metal and everything in between. The machine we're going to build is called the scalpel. The hardest part about creating your own CNC machine is, or could be, not having a CNC machine at your disposal, ironically. Why? Because you're going to need to cut some custom plates to create this beast. Fear not, we're here and we can help you with that. If you're one of the unlucky people that don't happen to have a CNC machine at your disposal to cut these parts, we can sell them to you for a reasonable price. So, how much is it going to cost you to build this beast? Well, depending on current pricing of some of the parts, it will cost you about $1,000, perhaps a little more or a little less if you can cut your own plates. If not, it may cost you upwards of $1,500 or more depending on who makes the plates for you. We do not have our pricing set up yet for our plates, but it will be listed very soon. We are not in the business of cutting plates, but we can do it for you if you absolutely have no other way. It may take us a bit to do that for you depending on demand and time available. The complete build for this unit has about 20 different plates, and they're all powder coated. We will be doing another video shortly showing you how you can powder coat your own plates to get them just the way you want. If you purchase the plates from us, we can powder coat them for you as well, but you'll need to specify the powder coat color that you want. In the next part of this video, I will include a complete parts list with links to purchase all of the parts you're going to need, and there'll also be a link there for you to order the plates should you need to. The complete build from beginning to end will take about 3 to 8 hours, depending on your own abilities. Personally, if I have all the parts ready to go, I can build one of these in about 4 hours. Then hooking up all the electronics may take me about an hour or two. Building this unit is just the beginning. After you build it, you're going to need to spend a fair amount of time tuning and calibrating it. While this task is not complicated or difficult, it will take patience on your part to get it right. However, once you lock in that calibration, you'll find that this is an awesome machine. It is a real powerful workhorse. The controller I'm using for mine is called a Tiny G. I like this controller because it supports chili pepper for the G-code center. I use this software because it allows me to auto-level the item being cut, which is perfect for cutting your own printed circuit boards. It is perfect for also cutting plates as well. Okay, to create my G-code, I use a program called ESTL-CAM. I'll put a link in the description down below to this. It's perfect for simple jobs and has a fair amount of features. It's about $60 and well worth the price. The Tiny G is available from a company called Symptos and has all the bells and whistles you would ever need for this unit, and it is reasonably priced at about $129. This is probably a good time for me to mention that I'm not being paid by any of these manufacturers to promote their products in any way. These are just ones that I happen to prefer myself. The Tiny G controller has 4 stepper motor drivers. It supports micro-stepping and has all the home stops, both upper and lower. It also comes with its own firmware already loaded and is easily configured to your setup in short order. I will include a video later on showing you how to perform this setup. The unit is using 4 175-ounce NEMA 23 stepper motors, which are plenty powerful for this setup. Please bear in mind that this unit here is setup is 500 by 500 millimeters in size. Each of these rails are 500 millimeters long, but you can substitute these rails with 1,000 millimeter length rails or 1,500 millimeter length rails, depending on how big or small you want to make this. It will affect the cost a little bit depending on which rails you choose. It is super sturdy and rock solid in its constructions. The axes have nearly zero give and nearly zero backlash. This thing is a true beast, to say the least. It weighs about 60 pounds. All of the linear rails in this were sourced from a company called Open Bills, and I'll put a link to that in the description down below. The router I'm using for the scalpel here is a DeWalt 611. That's this yellow thing right here. And you can certainly use any router you want or have for this. You'll just need to modify the mount so it fits correctly. This entire unit is screw driven. There are no belts and there are no pulleys. For the power supply, it's just using a standard 24 volt supply you can get on Amazon or anywhere. To construct this thing, you're going to need a few tools. You're going to need a 5mm hex driver, and I recommend you get a good one. I like the Husky one because it's well built and it does not seem to strip out any of the hex screws, which is always a problem when you're dealing with those. You're also going to need a 5mm tap and a drill that's just a bit smaller than 5mm to pre-drill the tapping holes. I also recommend some lubrication for tapping those holes, either WD-40 or some sort of cutting fluid. You're also going to need a soldering iron, solder, and a bit of wire. I use sprinkler wire for this, which can be purchased at any hardware store. Okay, if you want to get fancy, you can build a control box for this that's separate from the unit. I happen to build one that's underneath the unit, so I can make the whole unit portable and just carry it wherever I want, but you can do it whichever way you want. Just to let you know that all of the plates you see here on this unit were actually made right on this actual unit. I actually have another CNC machine that I own. It's an X-Car from Inventables. Again, not sponsoring them, just telling you what I got and what I've used. And that is how I cut the initial plates for this. The X-Carve is not a bad CNC machine. I mean, it's great for cutting wood and things like that, but cutting aluminum, it's just not rigid enough to handle it. So the initial plates I cut weren't that good, but they were good enough to get me going. Okay, after I had cut the initial plates on my X-Carve, I was able to recut them a whole lot better on the finished unit using the plates that I had created on the X-Carve. So these plates here were done on this rather than the X-Carve. Of course, the first plates I created worked, but they just weren't perfect. They were good enough to get me my next set of plates cut on the scalpel. And then, once I had the good plates, I was able to cut the plates you see here. So in total, I had to create 3 sets of plates before I got something that was perfect. Which I figured is not too bad considering where I started. Okay, this is going to be a multi-part video. I will not be showing construction from beginning to end. However, it's dirt simple to build this. If you have any questions about any part of the build, I'll be happy to answer them for you. Just comment down below. I'll be showing some of that build to help you with get started and like part orientation and what, you know, the tricky parts of the build to help you get started, and it should make it a lot easier to go. Well, for this introductory video, that's pretty much all I have for you today, but please be sure to subscribe to our channel and like our video, and stay tuned for part 2 of this video coming very soon. We are glad you could join us today on a little bit of everything. See you soon.